here's a typical titration curve problem. We have 20 milliliters, so we have a fixed amount of 0.35 molar hydrochloric acid, and we know hydrochloric acid is a strong acid. The titrant is 0.5 molar sodium hydroxide. That's the chemical that you add from the burette, so you have different amounts possible. And we're calculating 4 points on the titration curve. At the start of the experiment, before we get to the equivalence point, at the equivalence point, and past the equivalence point. So, to calculate the pH at point A, 0 milliliters of titrant added. The only thing we have in this solution is 20 milliliters of 0.35 molar hydrochloric acid. So this is a strong acid, and we know how to calculate the pH. We already did that. The pH should be 0.46. So try that one, set up the ice chart, see if you can calculate the pH as 0.46. The new things are points B, C, and D. And B, C, and D are all based on how many milliliters of titrant it takes to get to the equivalence point. So let's do a little stoichiometry to calculate how many milliliters of the sodium hydroxide does it take to reach the equivalence point in the titration of 20 milliliters of hydrochloric acid. We know the molarity of hydrochloric acid is 0.35, so 0.35 moles of hydrochloric acid per 1 liter, or 1,000 milliliters of solution. And we know that hydrochloric acid reacts with sodium hydroxide in a nice 1-to-1 ratio. We need that mole-to-mole ratio to turn 1 mole of hydrochloric acid into 1 mole of sodium hydroxide. And then the final calculation, moles of sodium hydroxide can be turned into milliliters. Using the known molarity again, the sodium hydroxide was 0.5 moles per liter. So the volume it takes to reach equivalence is 14 milliliters of sodium hydroxide. So that means equivalence is 14 milliliters of sodium hydroxide. Point B, 5 milliliters before equivalence, another way of saying that is 9 milliliters of titrant added. And point D, 5 milliliters past the equivalence point, would be 19 milliliters of sodium hydroxide added.